And the theorems are the limit of a polynomial is simply P of A. I know that this is a contradiction. Why is this a contradiction? Because I specifically said if we say x approaches A, that's what we mean, approaches A, which means x does not equal A. But here I am telling you to determine if this is a polynomial, to determine the limit of this function when x approaches A by simply plugging it in. It's because that's what the result would be. So this is one theorem. The second theorem is the limit of a rational function. Like, for example, the limit of x approaches A from a polynomial at the top over a polynomial in the denominator. So rational. So a polynomial over another polynomial. So this is the same thing. The same thing like here. I can write R of A, the function plugging in A. But there is a big if here, which we did not have with polynomials. Only if A is in the domain of this function. If A, little a, this number, 5, 10, pi, if A is in the domain of R of X. Otherwise, this does not work because I cannot get a number. Okay, so I have one other thing to show here, which is the Squeeze theorem, but I would like to practice. And feel free, if you'd like to choose, I will tell you the page number, or in order to move on, I can choose. So here is a first example. Let's determine the limit as x approaches 5 from x squared minus 5x plus 6 over x minus 5. So this is a limit of a function. This is something applied to a function, an operator, like the square root, like cube root, etc., etc. Please remember, we do not drop the limit operator till the very last step. I'm going to say it many times. I know I sound like a broken record. I'm sorry. I apologize from the beginning. Okay, so every time I'm asked to, where are my props? Every time I'm asked to determine a limit, I have to plug it in. I have to plug in 5. I have to replace x by 5. Why? Because I want to see if the answer is 1/2. If it is 1/2, I'm done. That's the answer. If it is 0 over 0, then I know there is hope. If it is 5 over 0, I know there is no hope. The limit will not exist. But because x approaches 5 from either side, I have to determine the limit from the left and the limit from the right. So let me say this one more time. I must plug in 5 in the function. If I get a number, I'm done. If I get 0 over 0, I have to think about it, and we'll talk about it. If I have a number over 0, not 5, it can be 4, it can be 10, it can be anything, 14. I don't want you to think that I copied the 5 from here. Any number, okay? 14 over 0. No hope, and we have to talk about the situation. Okay, so I'm doing this first. So 25 minus 25, that is 0. And 0 plus 6, the numerator is 6, and the denominator is 0. Oops. This is the situation. In that case, did I put in correctly? So did I copy it correctly? I think I copied correctly. Yes, everything is correct. Okay, so 25 minus 25 is 0 plus 6. Good. So if that's the case, then I have to analyze both left and right limits. So it's not a number. There is absolutely no hope for the limit to exist. But in this situation, I have three possibilities, and I do not know what to write. One possibility is the answer is infinity. The second possibility is negative infinity. And the third possibility is D and E. Because it's from either side, I do not know which one it is. Don't change anything, I will delete it. If I have this situation, I don't have to check the other one. The numerator approaches 6. The denominator 5 from the right is a number greater than 5. This quantity is positive, and I will write infinity. If I'm asked to simply determine the limit from the left only, I have again no problem. The top is positive. 5 from the left with 4.9. 4.9 minus 5 is negative, and this will be negative infinity. But no, I have from either side. If the limit is from either side and it's the situation in which I have 6 over 0, this I have to determine both limits, the one from the left, the one from the right, and then I will conclude here. Right now I have no conclusion. Okay, so let's take a look at the limit from the left, the limit from the right, and then conclude. Any questions so far? Can you follow? Anyone? Can you say anything, anyone?
Yes. Yes.
You will stop me if you don't. Okay. So limit as x approaches 5 from the left. X squared minus 5x plus 6 divided by x minus 5. We know the top is a positive number. It doesn't matter if I plug in from the left, from the right, the top is 6. The denominator, 5 from the left, means 4.9, but 4.9 minus 5 means negative. What do I write as the answer for the limit from the left? Very good, negative infinity. Is everyone okay with this?
Yes.
Okay, the other one.
I'm not exactly sure how you got there.
So when I have a number over 0, these are the possibilities. So the numerator, when I plugged in 5, I got a positive number. When I plugged in 5 from the left, which means with 4.9, 4.9 minus 5 is a negative number. Positive over negative is negative infinity.
All right.
Better?
Yes.
Very good. So x approaches 5 from the right of x squared minus 5x plus 6 over x minus 5. The top is still positive because it's 6. But can anyone tell us the sign in the denominator? 5 from the right.
Positive infinity.
Yes, because you will have to plug in 5.1 minus 5, which will be a positive answer. So positive over positive is infinity. And now, what do I conclude here? Because now I'm ready to conclude.
D and E.
Exactly. Once I determine the limit from the left and I determine the limit from the right, they do not match. It's D and E anyway, right? Negative infinity and infinity are not numbers. So these cannot be, the limit doesn't exist. So I know this does not exist, this does not exist, this does not exist. But if they're both positive infinity, I cannot write D and E. I have to write positive infinity. If they're both negative infinity, I cannot write D and E here. I have to write negative infinity. Any questions on this problem? Any questions? That was a very good starting point. Okay, let's continue with limit of the square root of 9 plus h minus 3 divided by h as h approaches 0. Can anyone remind us how we start? What is the starting point here?
Plug in 0.
Thank you. Very good. Okay, so where does the numerator go when we plug in 0?
0.
Excellent. Where does the denominator go when we plug in 0? I know it's silly. Good.
Also 0.
Good. So 0 over 0 we like because there is hope. Okay. Now, in order to eliminate this situation, do we remember what we normally do? And we don't really do it to numerators. We normally do it to the denominator. But in this case, I have to do this or apply this procedure to the numerator. What would that?
Conjugate.
Yes? Say it again.
Conjugate.
Yes. We have to rationalize the numerator. And indeed, we will rationalize it using the conjugate. So what do we mean by the conjugate? If this is a minus b, then we have to multiply by a plus b and divide by a plus b because this quantity has to equal 1. If I have a plus b, then I multiply by a minus b and divide by a minus b because the quantity has to equal 1. I'm not allowed to change the value. I'm allowed to change the outlook, the presentation, if it's the same. But I'm not allowed to change the value of the function. And multiplying by 1, there is no change. So I'm going to write it again. You don't have to. It's just because I wrote all that over there. So then the limit as h approaches 0 from the square root of 9 plus h minus 3 over h will be multiplied by, can anyone give us the conjugate again?
The square root of a plus h plus 3.
Good. Over the square root of 9 plus h plus 3. Sorry about that. It's 9. Thank you. Good. So now limit as h approaches 0. Notice again that the limit operator has to be in the problem at all times. The denominator is easy. 9 plus h plus 3. Can anyone give us this product?
Nine.
That's it?
That's h. Minus 9.
That's it. So a minus b, thank you, Sean, times a plus b, a minus b, times a plus b equals a squared, a squared minus b squared. As expected, as we know from the difference quotient, that's what this is. The terms without h must go away. Please don't simplify here. Write equal symbol, copy the limit operator again. Do not drop the limit operator, please. Limit as h approaches 0, h divided by h the square root of 9 plus h plus 3. Now I can simplify. Now I will drop the limit operator because I apply it to this function. What do I get?
Zero over square root of 9 plus h plus 3. 1. Ugh.
Very good. Over. Careful. H approaches 0.
3.
So from here, I have 9 plus 0, which is the square root is 3.
6.
6, indeed.
Yeah.
Very good. Any questions?
How did we get 6 on the bottom just now?
H approaches 0. How much is the square root of 9?
3. Minus 3.
Did you copy minus? I hope you didn't copy minus.
Oh, I read it as a minus because of the erase. Okay. It's 3 plus 3. Yeah, I see it now.
Good, excellent. Good. That was a rationalizing. Let's take a look at something like limit. There are so many different situations. So many different situations. Yes, please.
So at first you said not to simplify the operator, like H, like cross out the H's, but then when you're going to plug
No,
in
this is
zeros-
the operator. H is not an operator. This is the operator.
Okay, never mind. I got it. I'm good.
So this is the operator.
Okay.
H is just H.
Very-
So what I'm saying is, very good question. So this is the limit of this function, which I copied again, multiplied by, equals the limit of this function, equals the limit of this function. Now I apply the limit here, and I get 1/6.
Okay, I'm good. Thank
Better?
you.
Okay. Perfect. Next, I would like to look at, so we did a rationalizing. Let's look at a factoring situation. Yes. So let's look at limit as x approaches 5 again, from x squared minus 6x plus 5 divided by x minus 5. What is the starting point? Anyone?